Hello and welcome. In this video, I want to talk about derivatives of exponential functions. Let me remind you, exponential function is when you have a number raised to a variable power, like 4 to the x, or 10 to the x, or 3 to the 2x plus 1. And the most important exponential function is the natural exponential function, e to the x. And let me remind you, e is the constant number 2.71828, etc. Let us start with the derivative of the natural exponential function, or e to the x. Derivative of e to the x is e to the x. Very simple. E to the x is the only function that has this property. It is its own derivative. Derivative of e to the x is e to the x. Let's try some examples. For example, suppose we want to find derivative of the function y equals x cubed plus 2e to the x. This function has two terms, x to the third and 2e to the x. This part is exponential function, but note that this part is a power function. Don't confuse this part with the exponential function. To find derivative of the first term, we have to use power rule. Bring the power down to the front of the term as a coefficient and reduce the power. Note that in this term, the base of the function is a variable, but the power is constant. But in exponential function, the base is the constant, the power is variable. So, derivative of this function is 3x squared. Derivative of x cubed is 3x squared. And to find derivative of 2e to the x, we keep the coefficient, we write the coefficient, and we take derivative of the rest of the term. Derivative of e to the x is e to the x. Another example, x squared times e to the x. This function is the product of two functions, x squared and e to the x. So to find derivative of this function, we have to use product rule. Derivative of f times g is f first function, f is the first and g is the second function. F, write the first function, times derivative of second function, plus second function times derivative of the first function. So derivative of x squared e to the x is x squared, write the first function. What is the first function? X squared. We write the first function times derivative of second function. Derivative of e to the x is e to the x, plus write the second function. We write e to the x and we multiply it by derivative of the first function. What is derivative of x squared? 2x. And this is the derivative of the function. If you want, you can factor e to the x from the first and second term. So the answer can be written in this form. E to the x times x squared plus 2x. Now let's take a look at the derivative of general form of exponential functions, b to the x. Note that derivative of e to the x is e to the x. So derivative of b to the x is b to the x, but you have to tack on the natural logarithm of the base, in this case ln of b. So derivative of b to the x is b to the x ln of b. Note that in the case of e to the x, we have ln of e, but because ln of e is 1, and when you multiply 1 by something, nothing changes, ln of e is negligible. So derivative of e to the x is e to the x, and in general form, derivative of b to the x is b to the x ln of b. For example, derivative of 3 to the x is 3 to the x ln of 3. Another example, derivative of x squared plus 2 to the x. Derivative of x squared with the power rule is 2x, and derivative of 2 to the x is 2 to the x ln of 2. Another example, x times 7 to the x. In this example, the function is the product of two functions, x and 7 to the x. To find the derivative of this function, we use product rule. let me remind you product rule. Derivative of f times g is f g prime plus g f prime. So derivative of this function is, we write the first function x, we multiply it by derivative of the second function. Derivative of 7 to the x is 7 to the x ln of 7 plus write the second function 7 to the x times derivative of first function. Derivative of x is 1. And if we factor 7 to the x from the first and second term, we can rewrite the answer 7 to the x times x ln of 7 plus 1. If we combine derivative of exponential functions with chain rule, we get to these formulas. Derivative of e to the u is e to the u times derivative of u. du over dx is derivative of u. And this part is derivative of the inside. So in exponential functions, inside is the power, and the outside function is the exponential function. So derivative of e to the u is e to the u. This part is derivative of the outside function, leaving the inside function alone. The inside is u. We leave inside alone. Then we multiply it by derivative of the inside. What is inside? Inside is u, and we should multiply it by derivative of the inside function. Inside is the power. We should multiply it by derivative of the power. And in more general case, derivative of b to the u is b to the u ln of v. This part is derivative of the outside, leaving the inside alone. Then multiply it by derivative of inside. What is inside? The power. Take derivative of the power. Let's try some examples. Y equals e to the 4x. In this example, 4x is u. And note that derivative of e to the u is e to the u. So derivative of e to the 4x is e to the 4x. Multiply it by derivative of the power. What is derivative of 4x? 4. So derivative of the function is 4e to the 4x. Another example. Y equals 5 to the x squared. B, the base is 5 and the power is x squared. Derivative of b to the u is b to the u ln of b. Derivative of 5 to the x squared is 5 to the x squared ln of 5. Note that b to the u is b to the u ln of b. So 5 to the x squared is 5 to the x squared ln of 5. Then we should multiply it by derivative of the inside. Inside is the power. In exponential functions, inside is the power of the function. We should multiply this by derivative of x squared. What is derivative of x squared? 2x. And this is derivative of the function. Another example. E to the sine of x. Its derivative is e to the sine of x, e to the u, e to the u, e to the sine of x, e to the sine of x. Multiply it by derivative of the power. What is the derivative of sine? Cosine. And this is derivative of the function. Cosine of x times e to the sine of x. Another example. 3 to the tangent of x. The base is 3 and the power or u is tangent of x. Derivative of b to the u is b to the u ln of v. So derivative of this function is 3 to the tangent of x times ln of 3. Then we should multiply this by derivative of power. What is derivative of tangent of x? If you remember, derivative of tangent is secant squared. And this is derivative of the function. Another example. E to the cosine of 2x. E to the u. Derivative of e to the u is e to the u, e to the cosine of 2x. We should multiply this by derivative of the power. To find derivative of the power, we should use chain rule again because the power has inside and outside for itself. The inside is 2x and outside is cosine. First we take derivative of the outside. Derivative of cosine is negative sine. So derivative of this function is negative sine of 2x then multiply it by derivative of inside, and derivative of inside is 2. So derivative of the power is negative sine of 2x times 2. And if you want, you can rewrite it in this form: negative 2 sine of 2x times e to the cosine of 2x.